there, Convo friends. Welcome to episode 2 of Maai AI about types of AI. It took me a little while to get this episode together, and the reason for that was well, I started out by thinking let's just put some slides together, about different types of AI, different concepts, and a little explanation of why it's important. And then I found myself getting lost into this forest of terminology, of old terms, as in pre ChatGPT, that all of a sudden might need a new definition, and different types of AI where I'm like, am I even sure that I understand? So it took me a while. And what I bring to the table today is definitely not definitive nor authoritative. And I'd be really happy to hear what you think of this, whether you find it helpful and whether you would perhaps choose other perspectives to make even better like distinctions and clarifications. So this is more of a listing, an explanation of concepts of how they help me to make sense of all this, and hopefully they are helpful for you as well. So let's get started with some strategic disambiguation, because if you're a conversation designer like me, you know that we don't like our bots to make assumptions. If a question is not clear, what do? We disambiguate. We kind of, take things apart until they're completely clear and we know how to proceed. And, with the current day and age, with all this terminology just flying around, an AI bot, NLP, conversational AI, traditional bots, apps, agents, conversational interfaces, NLU, LLM bots, and AI assistants, I can imagine that you get a bit lost. That's how I felt when this all started. Like, okay, what can I still use of my old knowledge, my old terminology? What do I need to redefine? What do I need to reposition, even? And the reason why I feel it's really important to be precise about this is that, well, generative AI comes with its own set of promises and opportunities and, future visions, but it certainly also comes with its own set of challenges. And I feel that some of these challenges we might be able to mitigate completely or partially by using other pre-Gen AI solutions and technology. But in order to do that, we need to be very clear what it is that we're talking about so that we can also define, okay, what do we do with Gen AI? What do we do with non AI? What do we do with other types of AI? Because there's so much more out there in terms of AI than just Gen AI. Also, conversational interfaces, things just get confused. So, what I did is I made a little, yeah, I made a little checklist, basically my disambiguation guide. I defined 4 questions that help me to make sense of, okay, what am I looking at? What am I talking about here? First of all, first question, what is the interaction model? Second question, what type of AI are we talking about? Third question, does it involve natural language processing? And if so, where is the AI used in that natural language processing pipeline? In this little episode, I'll also pay attention to some other disambiguation between agents versus assistants and bots versus apps. And hopefully, at the end, we'll come to a more kind of shared understanding or even more questions. Either one is fine with me. So let's get started. My most important question when I'm looking at something is, okay, what's the interaction model here? Because if it's conversational, then it's definitely of interest to me. If it's not conversational, it used to be kind of not my cup of tea, but now with Gen AI, it might be different. So when we speak about conversational interaction models or conversational interaction, we basically mean interfaces whose primary input and output is language and words, where the nature of the interaction is a back and forth conversation over multiple turns, where the person's input is similar to how they'd say it to another person, and the system's output is meant to mimic natural language. Thank you, Rebecca and Diana, for this wonderful definition of a conversational interaction model in your book, Conversations with Things. I find it really helpful, and that's why I hope you don't mind me using it here. So, first question, do we have conversational interaction, yes or no? Well, let's have a look at some examples. Well, This one is pretty straightforward, right? This is Ro from Planned Parenthood, a pre-ChatGPT traditional chatbot, and it welcomes you in very natural conversational language. You can ask it a question and it will reply back with an answer again. So you can just keep talking to Ro and get some really wonderful advice on the side. An LLM-based chatbot, a bit more recent, of course, ChatGPT. Here, same thing. Hi, chat. Hello, how can I assist you today? Very conversational, multi-turn conversation, and you can just keep on talking endlessly. And well, LLMs are known for their very conversational nature, so this is definitely a conversational interface. Here's an example of a non-conversational interface, and here you probably go like, yeah, duh. This is a setup wizard. But if you look at the language that's used in the screen, setup will guide you through the installation. It's recommended that you close all the other applications. This will make it possible to update, blah, blah, blah. So the language is definitely colloquial. It's very kind of informal, and the user is addressed in a very direct way. Yet I have no way to reply back in my own language. I need to click next or cancel. And that's not even something I would say, right? A conversational alternative here would be, would you like to continue? And then for me, it would be yes or no. So this is definitely not conversational. This is GUI. So GUI, conversational interface, versus GUI, graphical user interface, visually oriented. However, with GenAI, we are seeing new flavors. If you look at Miro, here is a little note that I put on a Miro for my interaction designer, my front-end designer in Dutch. But if I click on this sticky, I have the possibility to access Miro Assist. And Miro Assist is a GenAI-driven assistant for me working with my Miro. However, this is not a conversational interface because the only thing I can do is actually select one of these options, for instance, rewrite for clarity or translate to English. And what it will give me back is the result of that transaction. Yet, as a GenAI designer, I definitely write the prompts for these kind of interfaces. So that's an interesting perspective. A conversation designer typically works on conversational interfaces. A GenAI designer has a bit of a wider scope. It's more about, hey, is there a prompt involved? So yes, there is natural language input, but not by the end user, but by the prompt engineer. And that's a very interesting shift in perspective. Another one, button bots. I mean, I love button bots. I have a very kind of, soft spot in my heart for button bots. And for me, they count as conversational interfaces. I know I'm probably not in the majority here, but because I cannot type or I cannot speak. But the content is very conversational, and the options also offer conversational options. It's not about next or back. And for me, this kind of is in parallel with what we often do in human conversation as well. Imagine you and me talking, and I show you an apple, I show you a pear, and I'm like, hey, which one do you want? And you point. That's very much a communication act between two humans. It's non-verbal, but it's definitely part of a conversation. So when you use button flows in combination with natural language processing for question recognition, for me, it's like on the border of both. There's no right or wrong, but I'd be really interested to see how you would feel about this kind of interface. Is this conversational, yes or no? And does it matter? So next question, we're leaving the interaction model and we are more focusing now on the AI. So if we talk about conversational AI, we now covered conversational and we're moving on to AI. There's many types of AI out there. And this might probably surprise you, but even rule-based AI is a thing. Rule-based AI is where we have a predefined model of human-made rules and logic, which consists mainly of if-then statements, so rules. And these rules have knowledge and logic encoded in them. and it's us that put that knowledge and logic in there. A rule-based AI is deterministic, and which means that as long as you input the same value, it will always output the same value because it goes through a rule, right? And as long as that rule doesn't change, the output doesn't change either. Here's an example of a rule-based AI, and this is Cookie, designed by Steve Wozniak. He's been around for quite a while, and he's been very patiently just compiling conversations and conversations and conversations into a system called, or a technology called case-based reasoning, which is basically rule-based AI. There's no machine learning, no statistics happening here. Everything here is based on rules. Yet it's very conversational because I can talk to Cookie like, she's the best out there, honestly. She's still a very amazing chatbot, even in the age of ChatGPT. Rule-based AI conversational. I think the most well-known example of rule-based AI, though, is non-conversational, namely all kinds of rule-based expert systems. For instance, here we've got a business process automation platform where we have large sets of data, extract data, we validate it, and then rather than throwing it into an LLM, no, we throw it into a rule-based model of business rules. And from there, there's a workflow with actions that are triggered. And the end result is not so much a conversation, but for instance, in this case, an invoice or a report or a list of decisions that can be input for the next step. So this is definitely rule-based. It's AI, but it's non-conversational because we are not talking with it. So next to rule-based AI, we have, of course, the other flavor. I just briefly mentioned it already, machine learning. And where rule-based AI is a model that's fed by our rules and logic, machine learning models are trained on data that you already have, historical data, for instance, customer question logs or things like that. And in the model, there's this algorithm that learns from the data, and typically this algorithm is designed by the platform solution supplier, right, or the data scientists. And these algorithms, they learn from the data, they take it, they discover patterns, and they can make decisions without me explicitly programming the model to do so. And based on the historical data and the pattern discovery and decision making, it will predict new output. Now, if you want a classical machine learning model to do new or different things, that doesn't happen automatically. No, you need to retrain the model by hand. And if you're a conversation designer or an AI trainer, you probably immediately think of, okay, I've got my natural language processing model, my NLU model for my chatbot. Customers start asking new questions. You do your daily or weekly analysis, and you find new questions that are not part yet of your intent model, of your machine learning model. You need to add those questions or lots of examples of those questions to a new intent in your model, and only then will it start recognizing these questions. So there's no automatic learning based on what it encounters. You need to take an active role in optimizing and improving your model. Here's an example of a machine learning-based AI that's conversational, namely a chatbot. Why do I know this is machine learning-based? I can recognize it from how it treats my question. I have a very specific question about my hand luggage, namely, can I take a banana with me in my hand luggage? And it kind of routes me to a topic, a high-level topic about luggage, which is perfect. And I can see, so apparently there has been the model has been trained with an intent for luggage, but of course my own little question won't be in there because it's a nonsense question. An LLM will probably kind of answer that question in a joking way and then refer to this information. But by the absence of that small talk and the direct relation between question and answer, I can tell, this is classic machine learning intent-based chatbot. Also, I happen to know the creator, so that's easy. An example of machine learning-based AI that's non-conversational is this machine learning for customer segmentation, where we again take a lot of data and we use machine learning to develop customer segments. And why do I know this is machine learning? Because over here it says k-mean clustering, which is a very well-known algorithm or step, if you will, in classical machine learning to kind of group information together based on what the model predicts. There's one more flavor of AI, and I guess you probably already know where I'm going, because within machine learning, we have deep learning. And contrary to machine learning, like classical machine learning, deep learning uses neural networks to learn from data. And neural networks are lots of layers of interconnected nodes. I've got a little image coming up in the third bullet, I think. And each layer has its own function. And the beauty of neural networks is that if your question changes or if your input changes, there's no need to retrain the model because it can learn new tasks during inference. And what inference is, we'll have a look at that in more detail a bit later on in this presentation. But if your deep learning model happens to be a large language model, the easiest way to think about it is you've got the model, and depending on how you prompt it, so depending on your input, it will kind of adapt to that input to give you an output that belongs together. And here you've got it. This is like a deep neural network with an input layer, an output layer, and in between there's loads and loads and loads of different hidden layers that you don't see, you can't influence. And what's very fascinating is that scientists don't even know how they work yet. And the more of these layers you add, the more of what we call emergent behavior becomes apparent. Very sci-fi. So, of course, an example of a deep learning-based AI that's conversational, ChatGPT. Non-conversational deep learning-based AI is, for instance, Netflix's recommendation system and other recommenders, which happened to start out as classic machine learning systems, which means that they basically did recommendations on features that were easy to train. So fixed features like name, location, perhaps some predefined preferences that the user themselves added. But now they are moving way and more and more into deep learning. And that means that they can also do recommendations on things that are not that tightly related or well defined. So that's very interesting. Third question, almost there, bear with me. Third question is, does it involve NLP? NLP is natural language processing. And natural language processing is the application of AI, so the field of application that deals with the interaction between computers and humans using natural language. Because the types of AI that we looked at, they can be applied in a whole range of topics and applications like um, um, image recognition, predictive analysis, algorithms to make self-driving cars. But for our scope, and especially for my own job as a conversation designer and a GenAI designer, it helps to kind of scope it down to everything that's language related. So that also means that I'm not talking about Dolly or Midjourney right now. I'm really focused on language related applications of AI. And natural language processing in itself is not so much a type of AI, but it's an application, which means, here's some examples, which means that natural language processing can be machine learning based, it can be deep learning based, and it can even be rule based or a combination of all three. So here is where it might get a little bit confusing, but hopefully the next few slides will help you make a little bit more sense of this. If we look at natural language processing for pre-ChatGPT bots, this is roughly how it works. We start by processing the input, and the input here can be text or speech. You type something in your little chatbot, or you say something to Alexa or Google Assistant. And when I say processing the input, I mean what we call pipeline steps, like tokenization, chopping up like the input into words in smaller units, parsing, lemmatization is a very typical one. Dependency parsing is like applying some linguistic structure about syntax. So there's all kinds of little steps that you can use to input to process your input. Another important step, and probably some probably one you will recognize, is to extract the user intent. So, especially in chatbots for customer service, when the user has a question, it's up to us to make sure that that question gets understood. And that typically means taking that one individual user question and mapping it to a more general classification, if you will, an intent. And that's what we call intent classification. Oh, let me just, yeah. Entity extraction is another well-known pipeline step, which is after intent classification, we go through the question again and we extract predefined units of data, units of information that help us make more sense of the question, like customer name, customer country, or for instance, very random example, a pizza topping. That's also an entity. We need to keep track of dialogue routing somehow, because once we have the right question and recognized it, of course, we need to kind of generate a response. So we need to route that question to the right place where the response can be found. And once that response has been found, we get a response and the user gets it returned. This first part of the natural language processing pipeline is what we call natural language understanding, or NLU. The second one, and that's a bit misleading nowadays, was traditionally called natural language generation. However, pre-ChatGPT, that mostly meant retrieving the flow that I, as a conversation designer, created and showing the final node of that flow that contained a response that I wrote. Or it meant fulfillment, meaning, okay, go to a backend system, retrieve the data there, and display it to the user in a way that makes sense, is usable, and actually answers the question. Nowadays, with ChatGPT, we're talking about natural language generation in the sense of a large language model generating the answer. This was not happening before ChatGPT, right? So natural language generation is a bit of a misleading term nowadays, because here we don't generate anything. We return a pre-written, predefined response. What's wrong with my mouse? If we look at ChatGPT or LLM-based bots, NLP works a little bit different in the sense that a large language model, so sorry about that, little interruption. So a large language model is pre-trained with a lot of text data. And what's really special about that somewhere in the data set, the NLU steps that we mentioned in the previous slide that we had a look at, like tokenization, intent classification, and stuff like that, are kind of encoded as what we call emergent capabilities. This sounds very sci-fi, but it basically means that we don't have explicit NLU steps as we did with the pre-ChatGPT chatbots. So we don't do lemmatization or syntactic parsing. No, these features emerge during pre-training. And that means that we can't actually train a large language model on understanding our specific questions. And that's also why we need RAG, for instance, to make an LLM aware of my specific situation or my company's specific situation. Because we cannot add customer questions to a large language model. That's not how it works. So instead of having explicit user modifiable NLU, we've got what we call an inference stage, where we take the input, which in this case is a prompt, like a user question, a user input, and that we can that we can further augment or enrich with a useful context information that we add to the prompt, either directly by just putting it in there or indirectly by retrieving it from a vector database, which is RAG. These are big steps, I know, and don't worry about that. And then we generate an output. And here, of course, we have proper natural language generation, because it's actually the LLM that generates the output. We don't write it. It's the LLM that takes care of what's appearing on the screen. Question number 4. This is the final question. If we have NLP, where is the AI happening? If the AI is happening at the question recognition side, then we typically are dealing with an intent-based or NLU-based bot, where the question recognition is handled by NLU with these explicit natural language processing steps, and the responses are written by humans. If the AI is happening at the response generation side, then chances are almost 100% that we're dealing with an LLM-based bot, where the question recognition is done by inference. So it's not so much the question recognition, but it's more like, okay, this is the input. We're going to complete it with an answer, with an output that together makes sense. And the responses are generated by the LLM, by the bot itself. Of course, there's also the possibility increasingly nowadays to have like a mix where both NLU and NLG are used. And in that case, we're probably dealing with a hybrid bot where NLU is used for the broad question recognition, for routing the question to the right domain, and also making sure that high risk questions always are routed to the same answer. And LLMs are used for response generation, typically in long tail questions, also as conversational glue to make things a little bit more, natural, a little bit more interactive and engaging, and also for personalization. I wouldn't recommend using LLMs only for generating the responses because of hallucinations, even if you use RAG. LLMs also, and this is really nice, are used for supporting the natural language understanding process, so the intent classification process. And that for me, as an AI trainer, I mean, I love training intent models, but it's a lot of work, it's difficult, and it's hard to get right. So if you can use LLMs to augment your intent classification, that is a very, very nice use case. Okay, almost there. Two more things to go. Disambiguation, agents versus assistants. An AI agent, as I know it, is a way to describe autonomous systems that are often embedded in larger systems or ecosystems, like, algorithms in self-driving cars, and that are particularly designed to perform complex tasks and real-time decisions. Whereas AI assistants, in my book, are user-facing bots, user-facing conversational interfaces like customer support bots, Siri, Alexa. Siri and Alexa are more like general purpose, ChatGPT as well. Whereas customer support bots are, of course, very narrowly scoped to the specific domain of one company. And these are typically handling routine tasks like switching on the lights, switching on the radio, answer questions, fetch information, and solve customer problems. So if it's user facing, autonomous, and makes real time decisions, then for me it's an agent. Otherwise, I would prefer to call it an AI assistant. Now, I can hear you say, hey, but aren't we designing agents nowadays? Well, yes and no. I probably would prefer the term agentic workflows, where we use a collection of components, which can be one or more LLMs, but also search, compute, rule based logic, integrations with other systems, and perhaps even, references to outward sources of truth to design workflows. So, not so much conversations, but workflows where these components can work together to automate a process or reach a certain goal. These workflows still rely on manual design. It's in the end, it's me who has to design, okay, what goes in there? What is the input requirement? What needs to come out? And how do I orchestrate all these different components to reach the end result that I envision? And that's okay for my client. And that typically looks something like this, where we have a user input, where we can do some prompting using the user input to create a little, package that the system has to work with. We can query some data sources in between, prompt them again, store everything as variables, generate some images with Dolly through the API, then make a final prompt where we bring everything together. By the way, this is a block generator, and output it in a document. So that for me is agentic workflows, and I think there's a lot of potential there for people like us, conversation designers and GenAI designers, to build these workflows. Final one, bots versus apps. I catch myself talking about apps more and more these days. Bots for me are more focused on questions and broader problem solving and have a very open scope. Basically, as long as it's within the scope of your bot, you can just ask anything and it will probably answer or not. And they have a conversational interface. Apps, on the other hand, are very kind of single focused and especially single specific workflow focused. So the blog generator that I showed you the little workflow for has a front end with 4 buttons. What kind of blog post are you looking to write? It will then collect some information, do some internet search, and combine that into a blog post, if you will. And therefore, it typically has a mix of GUI and CUI, so graphical user interface, conversational user interface, and limited to no conversational digression. So you can't really talk with it. That's it. We've reached the end of my disambiguation guide. I hope things got a bit clearer for you. And let's see, if we can take this hubbub, this little chaos of terminology, and put it into something a bit more structured, where an AI bot is any chatbot that uses some kind of AI, not necessarily generative AI. A traditional chatbot is a chatbot that predates the advent of large language models. That is today. We don't know what this might mean in a year. LLM bots are chatbots that use generative AI for both question recognition and response generation. Hybrid bots use both LLMs and NLU. Conversational interfaces is any human machine interface that uses natural language as its primary interaction model. And I'm looking at this, even if it's not using AI, is that even possible? I'm not quite sure. Well, perhaps the button bot, I'm not sure. What do you think? Conversational AI is any human machine interface, blah, 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 and uses AI. NLP, natural language processing, is the application of AI that deals with the interaction between computers and humans using natural language. NLU is the subfield of NLP that focuses on comprehending and interpreting human language. NLG, natural language generation, is the other subfield of NLP that focuses on automatic production of human language from data. Ooh, AI assistants are conversational interfaces, user facing, designed for handling routine tasks, answering questions, and fetching information. AI agents, on the other hand, are autonomous systems embedded in larger environments that are designed to perform complex tasks and take real time decisions. And generative AI apps focus on workflows that complete a specific user task. Well, I hope you found this helpful. Congratulations if you made this so far. If you're interested, I still have a few slots open on my course on GenAI design, and I'm looking forward to hearing what you thought of this and whether it was helpful for you. Groetjes, talk soon.